More than 30 years ago, we trained our eyes toward the stars as the first humans orbited the Earth. In the 70s, we looked up again toward the heavens to see humans actually living and working in orbit, and witness cooperation in space by bitter adversaries. By the early 1980s, the Space Shuttle was streaking toward orbit in the name of technology and discovery. But the 90s will be remembered as the beginning of a new era of space exploration, the development of the International Space Station. The world's largest laboratory in space will support scientific and technical research performed on Earth by taking advantage of the unique environment of space. This orbiting complex will remain aloft for up to 15 years and will allow scientists to accelerate the rate of discovery and invention for practical applications in health, medicine, materials, and technology. Researchers will use the International Space Station to conduct experiments in 5 scientific areas. Research in biotechnology will enhance our ability to accurately characterize human proteins, enzymes, and viruses at the molecular level by studying protein crystals grown in microgravity. Scientists may then develop better medicines to fight against AIDS, cancer, diabetes, and many other diseases. The International Space Station also opens a new window onto the human body's adaptation to a gravity-free environment. Exposure to microgravity can cause an otherwise healthy astronaut to experience rapid loss of bone mass, comparable to osteoporosis, but at a much faster rate. Until now, on-orbit research for U.S. investigators in this field was limited to short-duration flights on the shuttle. Now, extended investigations on the station offer new insights into the aging process. Fluid physics research will use microgravity to examine the behavior of liquids, gases, and mixtures. Private industry will utilize the results of these studies on the behavior of fluids in the absence of gravity to design more efficient production processes. Agriculture can also benefit from space station research. Biologists have long studied gravity's influence on living organisms. On the shuttle, scientists have performed studies subjecting both plants and animals to the sometimes adverse effects of weightlessness. On the station, this type of work would expand the fundamental knowledge that could benefit reproductive life cycles. This level of space-based research could one day lead to heightened produce harvest by allowing farmers to reduce growing cycles, thereby increasing crop yields. Experiments in other fields of study will seek advances that could improve technology in communications, computers, consumer electronics, energy efficiency, glass and ceramics and metals manufacturing here on Earth. Science will be performed by a multinational crew of astronauts, cosmonauts, and researchers. They will live and work on the International Space Station for up to 6 months at a time. The atmosphere inside the station is pressurized to a sea level pressure of 14.7 pounds per square inch, providing a comfortable living environment for crew members and an optimum operating environment for science research. The station is comprised of numerous interlocking components that are assembled on orbit one segment at a time. The station will be made up of 7 laboratories, living and sleeping quarters, life support systems, energy generators, modules for propulsion and attitude control, and other essential systems for navigation and communications. Building this space complex is a partnership of nations spanning the globe. Each contributes resources and scientific expertise based on technical knowledge, capability, and national interests. The ground-based construction of space station hardware began in the United States with the development of connecting modules or hubs called nodes. Later, halfway around the world, manufacturing began on the first building block for the world's largest space science platform, the Functional Cargo Block, better known by its Russian acronym, the FGB. This space vehicle, built by the Russians for the U.S., provides power and propulsion in the early months of on-orbit space station construction. The Russian Space Agency plans to contribute to the station a complex vehicle known as the Service Module, complete with living quarters, propulsion and navigation, as well as room for science experiments. Russia will also provide 3 smaller research vessels and an energy tower to augment the power capability of the station. Other elements being manufactured by the National Aeronautics and Space Administration and its contractors are a laboratory module, which can house close to 100 science experiments, living quarters for the crew members in the habitation module, and an airlock to allow for spacewalking tasks. The long truss structure supporting the station's power-producing solar arrays is the backbone of the orbital outpost. The complete station structure will have a wingspan of 356 feet, longer than the length of a football field. A robotic arm that runs the length of the truss to maneuver humans and hardware around the station is being built by the Canadian Space Agency. Agility of the arm is expanded through the use of a human-like robot, a smaller robotic extension that gives the astronauts a hand in conducting delicate work outside the space station. Another laboratory with numerous science experiments located both inside and outside the station is the Japanese pressurized module and its attached exposed facility. This exterior pallet allows astronauts to move experiments from the safety of the experiment module to the harsh environment of space. On top of Japan's laboratory is a smaller component that is used to store and resupply experiments. A smaller research module built by the European Space Agency offers yet another venue for scientists all over the world to see their life's work come to fruition on orbit. ASI, the Italian Space Agency, is building resupply vessels called mini-pressurized logistics modules, which will be flown to the station aboard the shuttle 4 times a year. These modules will hold food, equipment, and new experiments to be located in the station's various laboratories. Constructing space vehicles on the ground, then attaching them on orbit, will help each partner nation learn more about how to build, maintain, and operate large structures in space. Hauling hardware into orbit for the assembly of the space station requires 43 space flights on 3 different types of launch vehicles: the U.S. Space Shuttle, the Russian Proton booster rocket, and the Russian-built Soyuz booster. Once it is complete, the station will weigh over 1 million pounds and will be positioned in an orbit 220 miles above the Earth. The International Space Station will circle the planet every 90 minutes, traveling at a speed of 5 miles a second. Its orbit will be inclined 51.6 degrees to the equator, allowing the complex to travel over 85% of the Earth's surface every day. From this extraordinary vantage point, researchers will be able to conduct long-duration research on our planet's environment, its natural resources, as well as its atmospheric and oceanic conditions. This sprawling space campus will be controlled from both the Russian Mission Control Center outside of Moscow and Mission Control at the Johnson Space Center in Houston, Texas. As components from other partner nations reach orbit, a direct communications link will be established with each nation's Space Operations Center, providing a more effective means of interaction with science and research investigators in those countries. By the year 2000, the International Space Station expects to support the work of more than 1,000 scientists at universities and laboratories all over the world. Some researchers will have the opportunity to monitor their experiments as they're being conducted and communicate directly with the astronauts operating the experiment. This requires a complex communications network that will reach out from mission control to scientists throughout the country and possibly throughout the world. For the first time ever, long-duration spaceflight is available to an unprecedented number of scientists and engineers looking for answers to age-old questions. An orbiting laboratory virtually free of gravity will result in new insights and knowledge in scientific and technical fields in ways that cannot be achieved on Earth. Research on the International Space Station could touch the lives of almost everyone who is invested in this technology marvel. For the price of one night at the movies each year, the space station will become a symbol of the investment in America's future. a visible light in the sky for our children to look up at and dream about the wonder of space travel. Almost 4 decades after humans caught their first glimpse of Earth and the heavens from orbit, the International Space Station becomes a permanent home in space, to enable those with a curiosity to explore and those with an unquenching thirst for knowledge, to answer questions yet to be asked about our planet and the universe beyond. The International Space Station, the next step away from our planet.